Next we can see one more complex figure, that is a C section like this. Like this. The dimensions are, this is 14 centimeter, all are in centimeters, 14 centimeters. This is 8 centimeter. This distance is 20. This distance is 2. This is also 2. And this distance, this is also 2. We need to find the centroid of this whole area. So first of all, we will draw the centroid, reference axis. I'm drawing the reference axis here like this, x and y. So we need to find the axis, the distance of its centroid from this axis. Let this be O. How to find it out? So for that, we will divide this area, this complex area, into three shapes. That is like this. Say area number 1, area number 2, and area number 3. 3 areas. Now we will see the centroidal distances of each standard shape, that is rectangles, from this reference axis. For that, I am going to draw the same reference axis again here, and I am going to draw the first rectangle. So this is the first rectangle. This distance is 14 centimeters. This is 2. Okay. So it is easy to find the centroidal axis. So this will be x1 equal to 7. How we got it? 14 by 2. And this will be y1. y1 equal to 1. 2 by 2, that is 1 centimeter. Then for the second rectangle, we have like this. Okay, this distance is 2, and this distance is also, it is 20 centimeter. This is 20 centimeters. Now how to find out the centroidal distance from the reference axis? So this is the centroidal axis. So this will be x2 and this will be y2. And what will be x2? x2 is equal to 2 by 2 equal to 1 centimeter, and y2 is equal to 20 by 2 plus 2, because up to here 2 is there, then plus half of this distance, that is 20 by 2 equal to 10 plus 2 equal to 12. For the third area, we draw the same reference axis, and the third area is like this. So this distance is 2, this distance is 8, and its centroid will be like this. Okay, so the centroidal distance will be from the reference axis will be, this will be x3, and this will be y3. Okay, so what will be x3? x3 will be 8 by 2 equal to 4, and y3 will be equal to how much? This distance is 2 plus 20, 22. This distance is 22. 22 plus half of this distance. 2 plus 20 plus half. That is 2, 20 plus half. That means from here up to here. Total it will be 23, equal to 23 centimeters. So y3 is equal to 20 plus 2 plus 1 equal to 23 centimeters. Then for the area, A1 equal to 2 into 14 equal to 28 centimeter square. A2 equal to 2 into 20 equal to 40 centimeter square, and area A3 equal to 8 into 2 is equal to 16 centimeter square. So now we have all the distances, and the equation we use for finding out the centroidal distance from the reference axis is x bar equal to A1, in this case A1 x1 plus A2 x2 plus A3 x3 divided by A1 plus A2 plus A3, and y bar equal to A1 y1 plus A2 y2 plus A3 y3 divided by A1 plus A2 plus A3, as we have only three areas. So we have three areas, and A1 x1 plus A2 x2 plus A3 x3. If there are more number of areas, we will have to add like this. Okay, so we'll substitute the values now. For x bar equal to A1 is 28 into x1 is 7 plus A2 is 40 into x2 is 1 plus A3 is 16 into x3 is 4 divided by A1 is 28 plus A2 is 40 plus 16. You will get x bar equal to 3.57. Similarly, y bar equal to A1 y1 plus A2 y2 plus A3 y3 divided by A1 plus A2 plus A3. So A1 is 28, okay, y1 is equal to 1 plus A2 is 40 into y2 is 12 plus A3 is 16 into y3 is 23 divided by 28 plus 40 plus 16. This will give you y bar equal to 10.43. This will be 10.43. So the centroid of this complex area about this centroidal axis will be, or the centroid of this distance will be like this. So this will be centroid G, and its coordinates will be, G is 3.57, 10.43.